Hello everyone, my name is Yuyi Cai. I'm a master student from Esaki and Ochiai Lab in the University of Tokyo. Today I will talk about a new crowd monitoring system which is tolerant to MAC address randomization. This system only uses Wi-Fi packets, so no other things like installing extra applications are required. In addition, this system has a way to reduce the inference from MAC address randomization. To begin with, I will talk about the research background. Due to the rapid spread of wireless devices like notebooks and smartphones, researchers are trying to analyze people's position and action by using Wi-Fi packets. By analyzing, we will be able to do market research, crowdedness estimation, and other beneficial activities. For example, in the left case, we can get to know customers stay longer in shop B. Therefore, we can say that shop B is better than shop A in some ways, and it is worth researching. In the right case, there are more devices detected in area B. From this, we can say that area A is less crowded, and we can use this data to guide people where to go. In the past, we could use MAC addresses in probe requests to get the information of the surrounding devices. This is because MAC address was a unique parameter and the engineers thought people would not change it. However, there were some bad people who tried to identify and track people by monitoring MAC addresses. Therefore, from 2014, vendors began putting MAC address randomization system into their devices to protect users' privacy. This made it nearly impossible to count the number of devices accurately by counting the number of MAC addresses. So we need to make a new crowd monitoring system which is tolerant to MAC address randomization. It is nearly impossible to identify devices now, but here I will show that it is still possible to count the number of them. This is the order of my presentation. First, I will introduce previous research. Then, I will propose two methods, Bayesian and TrueSight. Finally, I will show you experiment result and future prospects. Firstly, I will talk about previous research. Satoshi Nakata proposed a concept that uses sending interval, sequence number, and receive signal strength indicator in addition to MAC addresses to estimate the number of devices. In their method, sending intervals are supposed to be same, sequence numbers are supposed to be consecutive, and RSSI are supposed not to change drastically. Unfortunately, they only proposed the concept and they did not show concrete procedures. Here, I will improve their method and show concrete procedures. Next, I will talk about one of my proposed methods, Bayesian. First, we will separate the devices into two groups. One is those which have established connection, and the other is not. So why is it necessary to separate the devices into two groups? This is because even if a device is doing MAC address randomization, it will basically not change its MAC address when it is connected to AP. Otherwise, the connection will be interrupted and terminated immediately. Then how can we separate these devices? We can know which device is connected to AP by watching data packets and beacon packets. Firstly, Data packets are transferred only when devices have established connection with AP. They contain MAC addresses of both devices and AP. Second, beacon packets are sent to notify AP's MAC address to the surrounding devices. They contain MAC addresses of AP. Unlike devices, AP will not change its MAC address. By using this information, we can get to know MAC addresses which have established connection with AP. In this case, the number of MAC addresses is equal to the number of devices. By using the information shown in previous slide, we can identify MAC addresses which have not established connection with AP. These MAC addresses may be randomly generated, so we can't use them directly. In Vision, we can focus on frame body in probe request to estimate the number of the devices. So, frame body consists of multiple tag data, which contain tag number, tag length, and contents. Even if MAC address is randomized, all parameters except SSID parameter and DS parameter will not change. For instance, vendor specific will not change unless you perform hardware replacement. Since tag number and tag length are given in frame body, it is easy to remove SSID parameter and DS parameter from frame body. If two different probe requests have the same modified frame body, we can say that they are sent by one device. Here, I will introduce another proposed method, TrueSight. Vision has a non-negligible problem, so it can't distinguish devices with the same model properly, because they have a high chance to use the same frame body. So we need to use a new parameter other than frame body to distinguish them properly. In TrueSight, I suggest we can use sequence numbers in sequential control to solve this problem. To get the number of devices using sequence numbers, we can use single linkage method, one kind of hierarchical clustering methods. The number of clusters made by hierarchical clustering will be the number of devices. In this case, there are 3 clusters observed, so we can say there are 3 devices. This is a diagram of Vision and TrueSight. So we can sieve devices by data packets, frame body, and sequence numbers to estimate the number of devices. So from this side, I will talk about experiments on Vision. This experiment was carried out for 7 days to check if Vision works properly. So we classified all the MAC addresses detected into 3 groups. One is MAC addresses of AP, another is those of devices transferring data packets, and the other is those of devices not transferring data packets. Besides, we also recorded all the frame bodies detected and checked the number of them. Of all the experiment results, I will show you analysis data in September 19th, which you can clearly see the influence of MAC address randomization. The purple line is MAC addresses which have already established connection with AP, and the green one is those which have not. And the light blue line is the number of frame body in the green group. The green line and the light blue one stay close until 10 a.m. but differ a lot after that time. I suppose this is because someone brought a device with MAC address randomization system into the area, and vision reduced the influence properly. From this part, I will talk about experiments on TrueSight. So I try to create the situation that there are multiple devices with the same model and MAC address randomization system and no other devices in the same area. However, I found it nearly impossible without the help of microwave cutoff room. So I simulated this situation instead, generated sequence numbers, got the data, and performed hierarchical clustering to see if TrueSight would estimate the number of the devices properly. Here is a procedure of simulation and analyzation. Step 1 to step 5 is the simulation part to generate sequence number, and step 6 to step 7 is the analyzation part. In step 3, I add a random integer from 1 to 49. This is because in the experiment on vision, there is no device detected which its sequence numbers differ by 50 or more. In step 6, I set the threshold to 50. This is because it is guaranteed in step 3 that the difference between sequence numbers is less than 50. To reduce the influence of random number bias, this experiment was carried out for 10,000 times and recorded how many times TrueSight predicted the number of the devices correctly. Here is the experiment result when fixing the value of x and changing the value of y. Highlighted data means the predicted number of devices matches with the actual one. From the result, we can say when the number of probe requests per device goes up, the accuracy goes down. Therefore, we need to capture as few probe requests as possible to increase the accuracy. So next is the experiment result when fixing the value of y and changing the value of x. From this table, we can say when the number of devices goes up, the accuracy goes down. This is because the more devices there are, the higher chance sequence numbers become close. So TrueSight works to a certain extent, but it can't work properly if there are too many devices with the same model. So finally, I will talk about experiment results and future prospects. According to the experiment on vision, it is possible to predict the number of the devices while reducing the impact of MAC address randomization. However, we didn't actually count the number of the devices, so we couldn't check if the predicted number was accurate. Besides, according to the experiment on TrueSight, it is possible to distinguish devices with same model to a certain extent. However, TrueSight is only tested with simulated data, so I'm not sure if TrueSight will work in practical situations. To make the prediction more precise, we need to capture as few probe requests as possible, but we must capture at least one packet to make TrueSight work. According to the research made by Julian Freudinger, devices send their probe requests about once a minute. Therefore, setting capture time to 1 minute seems good for TrueSight to work, so my next goal is to test TrueSight in practical situations. This is the end of my presentation. Thank you for listening.